Okay, we are starting off with our journals for math. The first sheet I want you to put in is this sheet. This sheet is different words that have to do with when you would use those in a addition problem, a subtraction problem, multiplication problem, and division problem. You will probably be adding some more words to it. So for this page, just put them in, and then we are moving on to the next page you're going to put in. I would cut it out and put it in, and we're going to put place value chart. All right, this is the place value chart, and as you know, each digit has, wherever it's placed in the number, it has a value. We are really good at ones, tens, hundreds, thousands. We start to slip a little bit when we realize that it's 10,000s, 100,000s, millions, 10 millions. Everything has a pattern, guys, in math. You just have to find it. Here's the pattern. Here's your base. Now, this is called a period. There are 3 digits in every period. You know about the period because there's 3 digits and there's a comma separating the periods. This is another period, another 3 digits, but let's look how the pattern goes. You have the ones, the tens, the hundreds. This is the base. Here you have the thousands, your new base, 10,000s, 100,000s. You will have another period, and I gotta leave it going open because there's not 3 here. It just only goes millions, 10 millions, and what will go next is the hundreds million. Then we'll go to billions, and then trillions, but every one of those have. We also have a decimal is really, really small. That's what this is. This isn't a period, it's a decimal. We made it big here because he is huge. Everything on the left side of the decimal is a whole number. Everything on the right side of the decimal is a part of a whole. So we have a tenth, 100, 1,000, 10,000s, 100,000s, millions. The pattern is still going to continue. Here, you see the only difference is we don't have a 1. We can't break one whole one into a part, but we can break one whole one into tenths. We can break it into 100 pieces. We can break it into 1,000 pieces, 10,000 pieces, 100,000 pieces, a millionth pieces, 10 millionths pieces, 100 millionths pieces. All right. So we'll work a little bit more with those place values, and it will help us a lot if we know the place value. If here it has no zeros. If it has 10, in 10 there is 1 0. So when we go this way on there, it is really taking it times 10. Every time we move, we're taking it times 10. If I am going this way on the place value, I am dividing by 10, or this is 1/10 of this. This is 1/10 of this number. This is 1/10 of this number. This is 1/10 of this number, depending on which way you go. If you're going right, your number is always going to get smaller. If you're going left, your number is always going to get larger. If you can make your number larger, you multiply. To make your number smaller, you divide. All right, we also have, let's put a number in here. We're just going to stick with that number for right now. I'm going to put my comma in there because I have a period here. There are the 3 ways to write that number that you guys learned in 4th grade. The standard form, which most kids like, is just writing the digits with the comma in there. That's your standard form. Expanded form is when you stretch it all out. So now we got to know the place value. What place is this in? it's in the 10,000s place. So we have 1 times 10,000 plus, what place is this? It's a 2 times, what place is it? 1,000 plus 4 times, what place is it in? The hundreds place, plus the 3 is in the 10th place, and the 4 is in the ones place. If we did it in written form, it would be 12,000. Notice we're at the end of a period, so guess what we're going to do? We're going to put a comma. 12,434. And we wrote it in expanded form. Now we will come back to the place value chart and we'll write another number later using a decimal. And we will do it in standard form, expanded form, and written form. All right, we got that done. Now we're moving on to the 4 properties. There are 4 properties. You use them all the time. You really, truly do. You just don't call them by their mathematical term. So the 4 properties we are talking about is identity property of addition. And the definition is when you add any number to 0, it equals that number. 4 plus 0, excuse me, equals 4. We also have the identity property of multiplication. When you multiply any number by 1, it is that number itself. All right, this is how I look at it, guys. Identity means you're looking at yourself in a mirror. If I have the 4 and I add it times the identity property, which is, or plus the identity property, which is 0, I see myself in the mirror. So I think of this as the mirror, the 0 for the 1. For the addition, I'm looking for my identity when I'm multiplying. If I'm a 10 and I take it times 1, I see myself in the mirror, the number 10. That's what the identity property is. All right, we're going to move on to the commutative property. Commutative property of addition and multiplication. Those are the only 2 that you can use it with. All right, if you change the order of the add-in or the factor, the answer stays the same. So the add-ins, let's just clarify what that is. Those are the digits that you add to make a sum. A factor are the digits you multiply together to get a product. So if you look here, I have 3 factors or add-ins. Doesn't matter which way I add them together, I'm still going to get the same sum all the time. And what this is looking at the numbers and saying, okay, how do I add the best? Do I know 4 plus 6 is 10 plus 7? I always like to get to the base 10 because it makes it easier, but some might like to do this. Some might like to do 13, 6 plus 7 plus 4. It doesn't matter. It's what works for you. Same thing with multiplying. 4, the factors of 4, 2, and 5. When you have just those 3 factors, I don't care what order you put them in, they're always going to equal 40. All right. Then we have the associative property. And that is a lot like the commutative property. Only difference is you can add and multiply any way that are grouped. Grouped is the difference. If they're in parentheses or brackets or braces, it doesn't matter how you add them. I can take 4 plus 6 plus 3 equals 13. If they're in the group, that means you do those first. So I would do 9 plus 4. Well, that doesn't work as well for me because I told you I like base 10. So I'm going to do 4 plus 6, group those, do those first, plus 3 equals 13. Multiplying, same thing. 6 times 2 times 4 equals 48. That's 12. I don't know my 12s, but I do know 2 times 4 is 8, and 8 times 6 is 48. So I would rather group them that way. called the associative property. The one we're going to work on, those you should have went through before. The one we're working on is the distributive property. I think this is the hardest one for kids, but really it's the one you use the most when you're learning how to multiply, divide, you're distributing it. Multiplication, a sum by the number is the same as multiplying each add-in by that number and then adding the product. Okay, that's a little confusing what the definition is, but is what it is in math, everything likes to be fair. So if you're going to be fair, then you want to do what I do to one, I have to do to the other. The break apart in multiplication is probably the one you're most familiar with, but you don't call it that. You don't call it the distributive property, you call it the break apart. So if I have 8 times 52, that's really hard for me to do, especially if I had to do it in my head. But if I did the break apart and I took 8 times 50, because the 5 is in the tens place, I know that's 400. And if I take 8 times 2, because if I take it times the first digit, one of the digits, I have to take it times both of the digits. 8 times 2 is 16. Oh, well, that's really easy. I just have to add those two together. Another example would be 8 times 70 minus 4. So I'm supposed to do 70 minus 4 first in the brackets. Well, then I'm still going to get 66. Well, 8 times 66 is pretty hard for me to do, but I could do 8 times 70, 560, and 8 times 4 is 32. Ooh, as long as I bring down that minus sign or whatever was in that bracket, then I distributed that 8 out equally between the two. Okay? And we'll go to note-taking number video 2.